There are 4 levels of DNS name resolution. 1. The local client's host file. 2. The local client's DNS resolver cache. 3. The DNS server's cache. And 4. The DNS server's zone databases. Knowing how these different levels of DNS name resolution work together can be crucial in resolving hostname to IP map problems and DNS issues. Let's look at 4 layers of host to IP name resolution. And basically every system, whether it's a server or workstation, has to kind of navigate through these 4 different layers. The very first thing we want to look at is the host file. And on a 2008 or Windows 7 or Vista system, or even XP, it's located in Windows. And we want to go to System32 and drivers and the etc folder, etc. Call it etc. I like to do that with Linux anyway, but it's just fun. We have to have some fun. And you can put entries in your host file, and you think about it. In the old days, say pre-ARPANET, there wasn't really DNS, and so you had universities and organizations, and they just maintained these really large host files. And you can still do that to this day, but of course, maintaining millions of entries and host files on millions of machines would be impractical. So DNS is a better means of name resolution. But this host file still exists, it's still there. And why might you use it? Well, there are several reasons. Maybe you want to implement some kind of fault tolerance on your client. So if your DNS servers go down, if I add entries in here, let's say for Galactica, let me do what is Galactica? Alright, and 109.207.13. As long as they're static and they don't change, then that would give me some fault tolerance in case my DNS server crashed. So that's one advantage. Another advantage, it's faster. I don't have to go out and do an iterative or recursive query to a DNS server. If I could just load it from my host file right into my client's DNS resolver cache, it's going to resolve a lot faster. So there are several performance and fault tolerance advantages to doing that. But there's no such thing as a free lunch. The disadvantages, imagine trying to do that on 100 or 1,000 machines. It's not going to be a very convenient way to manage host to IP mappings, hence DNS. But a lot of organizations, a lot of IT administrators will use a combination of DNS and the host file on certain machines. And you can certainly configure the host file on your machine to improve performance. If you want to tweak name resolution performance, and you just want to make sure that these are static IPs and they don't change often. Otherwise, you're going to have to update your host file all the time. And it will, a Windows system is going to check here first, the host file. And if it sees an entry there that matches a host to IP mapping, it's not going to bother querying DNS server. So if this is wrong, then you're not going to be able to resolve the host name. And you'll notice a lot of spyware and malware and things will sometimes infect your host file with bad entries. And you type in yahoo.com and instead it goes to stealmycreditcard.com or hijackmybrowser.com or whatever other website they redirect you to. So that's kind of the common technique with spyware and malware as well. But just to show you, let's make an entry here. And I'm going to pull this out, and we'll use Galactica's IP address, but I'm just going to put an entry in here, banana, in my host file. And I'm going to save it. And now I'm going to go here, right click, run as administrator. I'm going to use the command ipconfig, I want to flush DNS. That'll flush out my resolver cache. The reason is I want to start with a clean slate to show you what it looks like as we resolve host names through different layers of name resolutions. Right now we're at the host file layer, but notice it loads that automatically into my resolver cache. There's banana, okay, mapped to 150.13.207, 189. That's the pointer. But if I were to ping something, let's say that's not in my host file. Alright, Yahoo's not in my host file. You can see here it's not. Once I do that, watch, I'll display my resolver cache. And again, that information will be cached. Okay, and let me go up here. And let's see, let me get past banana. Alright, so there's Yahoo. And notice there's a TTL, or a time to live value. Okay, and this is in seconds. And when the TTL expires, it'll go out and query a DNS server again, either via iterative or a recursive query. And remember, in a recursive query, it puts the work on the DNS server. It takes the responsibility of trying to give you the best answer. And an iterative query kind of puts the work on the client. But once I've done that once, to improve or tweak the efficiency, both Linux and Windows will load it into a resolver cache. And that way, if I were to ping Yahoo again, and the TTL has not expired, then it doesn't have to go out and look at a top-level DNS server. It can pull it right out of the resolver cache. So it's faster, it's more efficient. Okay, so that's sort of the first layer we were looking at in name resolution was the host file. The second layer was the local client resolver cache. Okay. Now, in addition to that, there is also a server. There's a DNS server cache. Remember, a while back we were configuring a cache-only DNS server. Okay, and I can clear my cache here a bit. This maintains the cache for any host on my local area network that's using this DNS server to resolve host name to IP mappings. And again, the idea is to improve or tweak the performance so that you don't have to go through these repetitive, recursive, and iterative queries every single time. Good grief, if you can pull it out of the cache, it's going to be faster. Think of a proxy server, the same thing. One person in your organization loads Yahoo's webpage, and it might take a few seconds to pull it down off the internet, but then it caches it locally on the hard drive of the proxy server, and when the next person in your organization goes to Yahoo, boom, it pops up really quick. The DNS server's cache can kind of act like that. So far we've had the host file, the local host file, the local client resolver cache, which is that's for each individual workstation, it's different. The DNS server cache, and in this case that's for everybody in the organization using that DNS. And then finally there's the DNS server itself with all these A records and things that we have created. And again, here I have an entry in my host file, but let's create a conflict and see what happens with precedence. Okay, so I'm going to create. I have an entry in my host file that maps to 192.168.150, and the host name is banana. And the host file will actually be preferred, right? It's if we look at this in terms of layers, layer 1 is the host file, layer 2 is the client resolver cache, layer 3 is the DNS server cache, and layer 4 are the records stored in the DNS server itself, or if it has forwarders, any recursive or iterative queries it sends to forwarders or root hence as well. But let's go ahead and create a conflict. So I'm going to do a new A record, and I'm going to do banana, and I'm going to give this a bad IP. So let's say 199.207.13. I don't think anybody is. We do 120. I know nobody's there at 120. And I don't want to. Let me not create that. I make a. Oops! I made an alias there for banana. Hang on. Let me get rid of my alias. Boy, I'm trying to create a conflict and I can't. But when I don't want to create a conflict, okay, it's the cuckoo clock because I'm cuckoo for Cocoa Puffs. Alright, so now let me make a conflict. Got rid of my alias there. I'm going to add just a plain old A record. And 199.207.13.120. So that's a bad IP. Won't give me any echo replies. Won't be able to find anything. And let me add that. Okay, so I have banana here that points to nothing. Bad IP. And then I have banana here in my host file that does point to a valid IP. So let's see which is preferred. Let me bring my command prompt back up. And let's flush our resolver cache to clean out all that information. So we can start with a clean slate. flush the resolver cache, and let me display the resolver cache. And okay, notice here, and if you look, not from my DNS server, but it's the record from my host file. And if I were to ping banana, see? So even though there's a conflict that we created, this points to a bad IP, this points to a good one. This is at the first layer, right? In order of precedence, this is evaluated. It's dominant over any entries that would be on my DNS server. So you can kind of see how that works. Name resolution from the host file to the local resolver cache to the DNS server's cache, and then finally to the A records in the DNS server itself.